Welcome to this video. We do something really interesting today where we look into modern data stack setups and we look into modern platform setups, which maybe you don't really have an idea what it is, but we make sure that you get the idea in the next 45 minutes. And I don't do this alone. So hi, Zachary. Thanks for joining me. And before we get started to look into what modern data platforms are, can you quickly introduce yourself and what you are doing at Rivery?
Yeah, Timo, thanks for having me. My name is Zach Cie, and I'm a senior solutions engineer here at Rivery. I'm happy to be here. So pretty much what I do at Rivery is I kind of help our different prospects as well as customers better understand, our platform as well as how they can utilize it to the best of their ability to kind of build out their data stack and kind of get the data where they want in the format that they want as well. Yeah, but nice to be here and thanks for having me.
This is great. I mean, this is really like the part where we look into. So what we want to do today is we want to basically show two things. So first thing is we want to show, okay, how does a typical modern data stack setup look like? And what's the difference to what we call a modern data platform, which Rivery is? And so what are the trade-offs from, let's say, a modern data stack and how you can solve this with a modern data platform? So this is part one. Part two is also very interesting because it's a very regular use case. It's we want to show how you can sync up data that you have in BigQuery into Snowflake. So at least I would say in every third or fourth project that I'm working on, this is often a use case that we have things where some kind of data sits in a different kind of warehouse, but it's not really used there actively. And so people want to consolidate everything in their, let's say, major production warehouse, which is really often Snowflake. And this is also why we picked this example to show how you can sync up something from BigQuery into Snowflake. And so we would do this in one, the modern data stack version, and two, in the modern data platform version. Before we look a little bit deeper into modern data platform, can you maybe in short words describe how you would define a modern data platform, and also how would you explain what Rivery does?
Yeah, so I would say Rivery is what we'd say is going to be a modern data platform. So for us, what that means is it's a full end-to-end process of managing your data from wherever that sits currently, where you want to get it, as well as anything downstream that happens to that data, right? So whereas a modern data stack includes different products that kind of handle ingestion, transformation, as well as sending out or activating that data, what we see the modern data platform or Rivery to be is a way that, where all of that can kind of be consolidated, where Rivery kind of can handle everything from ingestion to push down transformation that utilizes your cloud data warehouse compute, all the way to things like data activation if you want to push data out or refresh a dashboard as well. So kind of more over-encompassing of that entire process and a more holistic view where it's all kind of consolidated. One thing I would kind of note within that is that what we consider the modern data platform is more closed but still open. So if you still wanted to use something like dbt as your transformation step but wanted to use the modern data platform to kind of orchestrate the entire thing, you could still do that. So you can switch in the part that you may want to use or may not want to use.
And I think this makes it really important because there are still people around who, how to say, have experienced the first period of data platforms, which was before the modern data stack. And there it was really close. It was a closed environment. So you usually had one platform. You had to cross your fingers that everything that you want to do was supported by this kind of platform. And this created a lot of frustration. And also these platforms were pretty expensive, often not really affordable, especially for smaller companies. And this was the nice thing that happens with the modern data stack, that it opened up a lot more possibilities. So, but let's have a more detailed look into this. So we prepared something for that. So let us share this. Yeah, we can look. I mean, we made an illustration of how a modern data stack and how a modern data platform can look like. And as you can see here, it's not really so different from the first glance. But let's say the magic is definitely in different areas, and so we want to highlight what it is. So I can start what makes a modern data stack, and then Zach, you can take over and can explain the part of the modern data platform. Modern data stack, as I already said, when the modern data stack came around, and I think the name at some point, I'm not even sure who created it, but at some point it dropped. But it was already there before that we saw, I think, first in storage. So we saw data warehouse solutions that were more capable and, of course, more accessible. For example, like Snowflake. Redshift maybe was the first one, then Snowflake, which then unlocked vendors that could create something that could support these kind of systems. So, for example, Today we look into Fivetran. Fivetran was one of the first big players who basically got into the extract and load stack, or let's say extract and load product, and they enabled like the access to specific kind of data sources that before was always custom pipelines. And everyone who built custom pipeline knows that it's not so much fun to build and maintain custom pipeline. So that was interesting. And then with the modern data stack, we saw basically a rise of all the different kind of tools that you could use to do all the different kind of steps that I just described here. So you could go from extracting, loading data, transform it to whatever data model you use. So I don't know, data vault or dimensional modeling or whatever. Then you can have a layer with your business logic, or maybe you can include specific kind of ML parts in there to enrich the data, and then at some point you push it out to application, and everything happens on the same storage ideally, which then is your data warehouse. And then you can have all the different kind of parts that help you to do this in a proper way. So you can add orchestration, data ops, data quality and monitoring. So it always sounds like paradise. So you have all the opportunities and you can do a lot of stuff. One of the things I think that we now learned after, 5-6 years of modern data stack is like the decoupling is definitely great, because like it gives you the opportunity to introduce a tool that helps you with a specific thing. But the errors are usually the thing that makes a lot of work and often like a lot of pain for people to bring everything in. It's like you have to couple all these things in the end to control them, because in the end you're responsible to deliver data in a data pipeline that is reliable, because like here on the application layer you can have a dashboard where people work with every day, and so you have to make sure that everything happens from here all works seamlessly together. And if something breaks and you have 6 tools, then you often really have not such a great job to basically figure out where your problem is. And so you can try to tackle it with something like orchestration. There are some data ops platform that can help you with monitoring and the whole thing. But again, like you stitch things together. It's doable, but it creates an extra effort. And so usually like it's also like then the reason that you might have 1 or 2 people who mostly do the integration parts in a data team between the different kind of steps. And as everything is evolving. And so for me, one of the most interesting evolutions of the modern data stack, what we call here like the modern data platform, which in the end, you already said it, like it's closed but open. So it's definitely not like the old ones. Maybe let's start with the basic. What would you say, what is the major difference? Because like the things what we do on a modern data platform are basically the same what we do in the modern data stack. So we also extract the load data, we transform it, we do other things. But what makes the big difference?
Yeah, so I would say like where the main benefits of like the modern data platform are still same as like what the modern data stack like provides you, right? So it gives you still like the cloud-based kind of architecture. It's easy to use, you get pay-per-use, it still runs on SQL. So all like the benefits that you have of the modern data stack, but it gives you kind of like that extra layer that you were kind of mentioning. So not only does it provide those, but it also gives you like a unified, like end-to-end way to kind of control data over your data pipeline. So whereas like in the modern data stack, you may be using like something like Fivetran or like HBR for the extract load, and then something like dbt for the transformation, and then something like high touch to write to your, applications, and then still having something like Airflow to kind of orchestrate that entire process. With a modern data platform, it kind of removes some of the friction between each of those systems, right? So like rather than, having to schedule, for example, your like extract and load to like schedule to run every like 30 minutes on those increments, and then like have that transformation run once a day and just hope that between that time, like it's going to be, completed and it'll be up to date. You can kind of have that data like, or that those processes run sequentially as dependencies for one another. So like having the extract load, and then once that completes, it then triggers like the transformation using either dbt or like push down SQL. And then once that completes, it'll run like the, the reverse ETL or like the data activation using like, post requests to other endpoints or like, something like that as well. And that's all kind of orchestrated, or that is all like, handled end to end by like the modern data platform. And we see like a lot of things like falling through the gaps sometimes, like, if your extract fails, then your transformation may still run, or like your reverse ETL or data activation process may still run. So kind of closing up some of those gaps that we see between like the modern data stack. So I'd say that's one of the benefits. Another kind of benefit is like with the modern data stack, there's always going to be like some bottleneck. So it's like bottleneck prone, right? So like since you have so many different tools, there's always going to be one that may, prevent like the ideal flow of data from happening, whether that be like when that transformation is triggered or like when that data is activated, or like, maybe like it may be the orchestration layer or even the extract layer. Kind of all of those things have their own dependencies that are kind of separate from each other. So it's kind of like disconnect. So with the modern data platform, that's a little bit more like consolidated, just because like it prevents that bottleneck by having each step be a dependency of its own within the same platform as well. So that's kind of one of the benefits. So kind of preventing those gaps between, eliminating some of those bottlenecks. And also like the last benefit I'd say is like some scale challenges as well. With the modern data platform, it automatically scales up and out depending on what you need to do, rather than going into each individual layer and kind of within the modern data stack and kind of, scaling those individually. The modern data platform would kind of handle all of those for you.
So I think these are really good points. I have three I would add. And so some you covered, let's say, already in one way, but I frame it a little bit differently. So like why I like to use modern data platform is like I get the operational foundation. I basically get baked in. And in modern data stack, I always have to build it in myself. So yes, of course, if I do my 10th modern data stack setup, I might already have some blueprints to do this, but it always depends on. I mean, it's rarely the case that I come somewhere and can say, I can dictate everything and I can introduce everything. So here the nice thing is on a modern data platform is like, when I create my account, this operational foundation is already there. So I don't really have to bring it in. Like the orchestration is already, what you just said, like the scalability is already there, like the monitoring is already there. So this is something I don't really have to take care of because it's already there. So it works even when we have the first very small increments of a setup, there it already works. And even like when we expand it, it still works. And so I think this is one of the benefits I really like. Then the other one is like what we already said is like this open part. So for example, like the storage is then still like a data warehouse, a Snowflake instance that is my Snowflake instance, so that I can do things with, and so yes, I can run, let's say, 90% of everything with my modern data platform. But since it's my instance, I can also do other things with the Snowflake instance. So it enables me to do different things. So I showed it here. Like I can use, I don't know, I have a specific enrichment process or enrichment product which helps me to, I don't know, enrich B2B context. So I can hook it up because like I have my Snowflake instance. So it's still open. And the third one, and this is definitely something that I learned over time with experience, and it's context switching. In the modern data stack, especially like this scenario what I just said before, like you figure out something in your pipeline that's not working, and you have to go through all the different kind of tools that are running this kind of thing. And it's always like a different context. So I always have to rethink, okay, how does it look in Fivetran? How does it look here? And so on. And the nice thing is like in modern data platform, I have one platform. So it usually works the same way in all the different kind of steps. So I have one structure. When I was starting to work more with modern data platform, this was something that, how to say, it was not obvious for me in the beginning, but when I was starting to think about this was definitely something that always brought me back. That I know I have one platform where I can do the stuff. And I don't have to think about, wait a second, where does this one step happening in which kind of tool set? So is there something still a step in between? And so this really helps me. So like I really love that I don't have to learn, let's say, different tools on the different kind of steps and relearn it again because I have to find out something. So this is still, I think, the part that I like most.
Yeah, no, I think that definitely makes sense. I like the context switching especially. I feel like, just like having that, like, removing that one barrier of having to see, like, go to different tools to kind of manage those different parts to figure out kind of what went wrong maybe within your data pipeline is really useful.
And it goes beyond that. I mean, it's like, so if you're a one-person team, yeah, so I mean, you still have the context switching, but at least like you don't have the problem that like you have to figure out, okay, who has access to what. But let's assume you have 10, 15 people. So like then someone tries to find out, so they are not created in this kind of tool, so they are missing the access rights. And so you create a lot of operational problems to basically get your team up and running. And so yes, there are also ways to handle this, but you have to handle this. And I mean, here it's nice. So you create one user, you give them specific kind of permissions, and they can do all the things that they should do across all the data pipelines. And I think this makes it really good. All right. I think this gives us a good idea what we can expect of, let's say, a modern data platform in comparison to a modern data stack. But I would say now it's a good time to do a real use case. And so as said, like this is the second thing that we want to show. is we want to show, okay, how can you sync up your BigQuery instance where you have specific kind of data, maybe your marketing team has specific kind of data, and you want to sync it up in your production data warehouse, which is in Snowflake. And I will go first. So I'm basically the modern data stack person. And so, of course, like Zach, you are the modern data platform person. So I will take care of the part where I show, okay, how you do this in Fivetran with the new BigQuery connector. And then you show how you can do it in Rivery. And we will talk a little bit about the different kind of approaches and what you can make with the differences. So how it fits to your use case. Okay, let's get this started. I go to Fivetran. So Fivetran, I mean, if anyone worked with this, it's a pretty straightforward platform. I still call it like Fivetran always like to call like the plug and play platform because like it's super easy to get started. This is great on the one hand, it can become a problem later on. And so we will discuss a little bit about that. As you can see, so I already tested a little bit, so you can already see a connector that we want to build, but I will guide you through how I basically create this connector between my BigQuery instance and my new Snowflake instance. Of course, what I can do is like it's with all the tools I have to choose where I want to get the data from. So in our case, it's BigQuery. And as you can see here, the BigQuery connector is in early access. So it's still like a beta feature. It worked fine for me, but there are still some limitations. So some limitations that I know. So maybe let's have a quick look here. So I have the documentation up here. There are some things, and I don't know if they will fix it in the future. Right now, they don't support it. So for example, you cannot export tables that have Google Analytics data, which is definitely a bummer because like I would say 80% of the use cases where I do a sync between BigQuery and another data warehouse is getting Google Analytics data somewhere because like marketing is using Google Analytics on their website, data setup is in Snowflake. They also want to have the GA data. So we cannot use it here. We don't know why. So it might come down because of the partition things, because like in the end, they also don't support partition tables. And the GA tables are by default partitions when they are loaded into BigQuery. So this might be the reason for it. So you have some limitations. This might be due to beta. We don't know because like it's not really mentioned here, but it's good to know for you if you're planning out to do something with Fivetran. And if you want to have GA data to a different place, nope, this will not work. And again, like when you already have partition tables, it will also not work. So we take an example where we don't have GA data and don't have partition table. What we will use is like we use a public data set, which is what is the long form of the MET? Is the Metropolitan Museum or?
Yeah, it's the Metropolitan Museum,
okay.
I think. Like right. Museum of Art, okay. Typically. Yeah.
Yeah. So there is a public data set on BigQuery. So one of the nice things also like BigQuery is like you have these nice public data sets that you can use for a specific kind of test. And we use one today. We take this public data set and basically load it over to Snowflake. And just let me go through. So I define what kind of prefix I want to use in Snowflake. And so I would go for BigQuery MET. So this should work. So then I have to provide my information about my BigQuery project and data set that I want to load and basically load into Snowflake. So my project ID is this one. I already created the authentication part. So this is usually like if you get started new and Fivetran, of course, like you have to provide the authentication part. Let's say the preferred way that Fivetran asks you to do is like to create or to basically add their service account to your GCP project and give this service account the proper access rights, which is, I think, just BigQuery user role, and then it works. So sometimes tools do it differently, so then you have to create it. We could do the same thing, so we could create our own service account and can then provide the JSON credentials for that. It works. So, but we have to make it authenticated. I created already this, so I don't have to do it now. Then we have the data set. So the data set, it's like, this is how the data set is called in my BigQuery project. It's demo met data. There's one reason why I call Fivetran plug and play, and this is like, it doesn't really take long to get going. And so like Fivetran is really great to get started. You might have some questions like, but maybe I don't want to load everything that we have here. So in the data set are 3 tables. And so there might be a scenario where I just want to have specific kind of data out of this and maybe not everything. So What Fivetran does now is like it tests everything. So it tests the connection, then it checks if the permissions are fine. Then we can continue, and then it checks the schema in BigQuery. Okay, I always say like Fivetran always goes with the best case. So, and it hopes that it's fine for you to go with the best case. So in the end, like at the moment, we do a lot of save and continue. So in the end, at least like here we get something that we can make a decision. Okay, how do we handle schema change for the future? So which can happen. I mean, it's like we don't really control what happens in the BigQuery data set. So it can be that the data is changed and we don't really have control about it. And here we can decide how we want to handle this. The interesting thing is what is missing here is like what happens when a schema is changed. So I might go with allow all. So, but I would assume when I go with this kind of option that Fivetran is then also like taking care of it. So I haven't tested it, but let's say I hope that it works like this, so that once the schema is changed, they will also try to apply the schema changes into my Snowflake instance. But this is something I would have to read up if I want to be 100% sure. I could also go for block all, which can make sense because like if this is an important pipeline for me, like I want to make sure that the stuff that I built on my Snowflake instance doesn't fail because like the schema gets changed. So this is like a decision you can make. It's like, okay, no, it's fine. It's maybe not so critical data. I go for all. Or it's really like, no, it's an essential pipeline and I need to get notified. But again, like you have to take care that you get this notification from Fivetran and you see it and you can react on that. But I want to block it. So I will go with allow all. So because like this is my first setup and this should be fine. And then I can start the initial sync. Again, it all works pretty fast and pretty quickly, but in this initial setup, it doesn't really give me a lot of options to configure it. And this is still like where I say like this makes a difference with Fivetran. It's like, yes, I later have some options. I can still go in here so I can change one or two things, but not really much. So in the end, like it's kind of take it all. And at some point we will discuss about costs. I mean, every data team at some point has to discuss about costs. And if you start to discuss about costs, you need control what kind of data you're loading. And this then, for example, can become one of the problems where you can say, yeah, it's really great. I can load the data pretty quickly, but I don't really have this fine-tuning options to say, yeah, maybe I don't really need everything of this data. Maybe I just need, I don't know, snapshots of this, or I want to filter it down because I already know that stuff is not there. And this makes it really complicated because like I don't really have so many options to do. But as you can see, I was just talking for some seconds and we have our initial sync already complete. So now we can see it's like the data from BigQuery has been loaded into Snowflake. That's great. So we will stop here with the Fivetran part and we will switch over to the Rivery part to have a look how this part would look like there. And then once we have done, we come back and we can look a little bit about, okay, can I do something more now? Or how would like a typical next step in the modern data stack look like?
So setting up the same BigQuery to Snowflake, river within Rivery, or pipeline within Rivery, can be done through what Rivery calls like rivers. So we're called Rivery. Our like data pipelines are essentially going to be called rivers. We have 3 different river types, like a source to target, a logic river, and an action. There's descriptions here, but really all we need to use for this initial ingestion is just the source to target river. So taking data from one source and then writing that into like our target, which is going to be Snowflake, right? So same thing, we can kind of just look for like BigQuery as a source over here and then click it over here. And all this is doing is this is actually utilizing an existing connection that I've already like added in for BigQuery. But if you need to add a new connection, you just click new connection and you can just use this information. You can fill out the information on the on the left-hand side. And then it gives you instructions on the right-hand side on kind of how to configure that as well, right? So it'll give you instructions on kind of adding that same like Rivery service account within your GCS instance or GCP kind of instance as well. And then you can test your connection to make sure it's working. Once the connection's also set up, you can also test the connection here within the UI. There's kind of 4 different stages for setting this up. There's configuring the source, which we just did, configuring the target. So we'll go to that next, the schema, and then the settings. So once you have your like BigQuery connection set up, and we'll just give this a title. So we'll call this like BigQuery to Snowflake. We'll give this a date, 15th of February, 2024. And we'll just put like metadata here. The next step would be to select our target, which is going to be the Snowflake data warehouse. So one thing over here is the same thing. You can just select the drop down if you have an existing connection. But if you have a new connection or want to create one for the first time, you just click on new connection and it gives you instructions on the right-hand side, and you can fill out that information on the left-hand side. One interesting thing to note is that kind of how the data moves is that we actually take the data from BigQuery, move it into like an intermediary stage, typically within like a custom file zone like GCS, S3, or like Azure Blob, and then move that into your Snowflake instance. So that's kind of like the default route, is that Rivery maintains like a managed file zone in between, and then it moves the data into your Snowflake instance, and then we clear the data after like 48 hours. But what you can actually do is you can actually add in a custom file zone for Snowflake, either S3 or Blob, so that none of the data would leave like your cloud instance. So like the data would go straight from like, your BigQuery instance into your own managed S3, and then from that managed S3 or Blob storage, you will move it into Snowflake. So a lot of people like this for security, PII information and stuff like that, just because none of the data would be staged on the Rivery side. So just something to kind of think about. And then you can also handle retention from that side. You get some auditability of like being able to look back there and see what like that raw data from BigQuery would look like. So we have an existing source or target connection already, so it's already preset here. And then you just have to type where you want to load this data. So there's some helper functions on the right-hand side too that pull in some of this information for you, but I'm just going to preload it since I know where I want to load it to. And then we'll just call this something like net data, and we'll put an underscore since this is just going to be the prefix. We also offer different loading modes as well. So you can run like an upsert merge, which merges on like a unique key or a set of unique keys if you want it. And you can configure this also within the schema tab. You can append the data. So this just adds the records at the bottom of the table, or you can even overwrite it. So if you wanted to truncate the table first and then replace it, you can do that as well. So kind of giving you that flexibility.
Which is really nice because like you really have this different kind of scenarios where you really want to make this decision how to do it. Because like whatever kind of source you have, all of the three can make totally sense. So
yeah, for sure. Yeah. So hopefully that like covers a lot of different use cases for a lot of different people as well. So after we finish the second tab, which is a target, the last one that we're going to go into before we kind of get this running is going to be the schema tab. So what this does is this actually just pulls directly from like the BigQuery instance and gives you all the different data sets that are available within your BigQuery instance. So you could select one of them. Let's say we select like this Rivery one. You can select all of them if you wanted to. And then this would pull all the tables within each one. And it'll even give you like the metadata for each of those tables. And you can go in, so it's loading the metadata right now. You can even go in and configure like how you want to extract the data. Like if you want to increment off a specific field or something like that, you can do that as well. So I'll deselect these right now since we're going to use...
How is it like with the restriction that we just saw on the Fivetran side? So can I load from partition tables? Like I can, let's say I have a partition table in BigQuery. Can I load this into Snowflake?
Yeah, so right now there is no partition support with Fivetran, but we do support partition tables within Rivery. So you'll see over here that when you configure like the specific table, you can actually click on it. And there's also instructions here on the different table settings or the extract methods. But over here, you can also add in different columns as well. And you can also add clustered keys and stuff like that as well.
And this is something which in the end, as I said, it's super easy to get started in Fivetran, but when you have more experience and if at some point you want to have more control, and I have, let's say I work with enough of sources which are pretty rich sources and where you have, let's say, pretty wide tables, let's say 200, 300 columns when you pull everything down. But you already know that in the end, you just use a specific kind of, you just need specific kind of data downstream. And so you can make the decision here to not load it because what you don't load, you don't have to pay for, you don't have to compute, and you don't have to do other things. So it gives you a lot of control how much you actually really want to get into the system, which is really helpful.
And then you can also configure the specific fields that you want inside. So you could remove certain columns as well if you wanted to, but really gives you that flexibility to kind of load what you want. Also, you can also select the key that you may want to merge on or set of keys. And this is going to be if you run the upsert merge, it actually concats them and then runs a full merge function into your Snowflake target table that you wanted to. And one thing I kind of did want to touch on is over here, that extract method again. This lets you modify how you want to pull the data. So you can actually pull the data by the last modified time. So it only pulls the latest records, but you can also pull any other field the metadata time, object end date, object begin date. And these are more specific to that table that we're pulling right now. But if there's any running number or date time or date field that you have within your data set, you could use that and iterate off of that. Just essentially just adds a where statement where the date is between this date and this date. But we kind of make it easy for you to set up with this. And you can include the end value and you can chunk out the requests as well. So a lot of different functions there that kind of just give you the ability to, choose how you want to pull the data. So hopefully you're only pulling the most relevant or the newest data rather than reloading or like rescanning the entire table each time. So we'll just do like an all for now, just to pull like all the data that is in this net projects table. And then all you have to do is click run, and then this is automatically going to run. So you'll see it's now saved and it's running. And the last thing I do want to show you is the settings tab. So from here, you can actually schedule this to run at whatever frequency that you want. So there's a lot of flexibility in the scheduling as well. You can schedule this to run at the highest frequency, which is like every 5 minutes, but you can also choose to run this, at a specific hour every day or every X hours. But we also give you like the ability to use like custom cron expressions as well. And then you can get notifications if there's like a failure or if there's a warning. And just to see kind of like the status of it, you can also check on like the activities tab, and you can kind of click over here and you can see like the run or the specific run for the specific instance as well. And you'll see like how much data has been pulled, and you'll see like the start date and end date that it's utilizing as like the input parameters.
And you get a lot of details. I mean, this is also helpful.
Yeah, and not only that is you can also click on the overarching like activities page, and you can see like all the different runs from like the last 7 days, for example. And you'll see like that one run that we're using over here again.
Okay, that's good. So while this is getting ready, so we can then maybe have a look. Okay, what do we next? I mean, this is I'd say part one, but of course, like data pipelines is like it's usually like extracts, like just the first part. And so when we look a little bit, let's say in the modern data stack example, and so let me go back to Fivetran and maybe also like go back a little bit here. So we just did that. So we extracted and loaded. So we did it here on this side. So we extracted and loaded the data, but this is unfortunately not the state where we can stop working, because like we have to do a lot of things in between. So we won't go into why we do all these things in between, but in the end, like source data comes how the source has generated the data. And so it's usually not like that the source data matches how we want to represent the data finally. So if we want to build some dashboards, if we want to, I don't know, have some ML applications that we have to get the data in the right state that it can work with this. And this is usually like the things that are happening in between. So this is the natural next step. So we loaded it with Fivetran, and we touched it a little bit before. It's like once this is done, and here we have the same thing. So we could now, in the end, like in the setup, we could say, okay, how often do I want to run it? In the end, I think here, I think 5 minutes is also like, I think this one, right. Yeah, so exactly. So this can cause problems, but in the end, then I can check, okay, this might run every night at 2 o'clock, but I have to then plan what I do next. And this is often like, this is a little bit the disconnect. So for example, I have 10 transformation that I want to run with there. So a transformation can happen in a totally different system. The only way that I have, I mean, you already see the CN5, and it's like, I have also like the possibilities to run transformations here, which in the end is like mostly that I can basically use a dbt core instance and can let it run and orchestrate within Fivetran, which can work fine if this is like your only thing that you do. So if you really have just Fivetran, then just dbt, and then that's it. So then it can work. But at least like in my experience, you often have different kind of sources. So we have some that are supported by Fivetran, and some that you still let then run with custom pipelines. And then you cannot fully orchestrate everything because like it's not really there. But here you can see. So you have either you can use the dbt core integration. So in the end, like you have a project with dbt somewhere in your GitHub, and then you can connect it to here, and then Fivetran can run it for you in the end. So they do the same thing, or they do part of the same thing what dbt cloud does. But for example, you could also use dbt cloud, then Fivetran would trigger dbt cloud based on your configuration. But let's say these are the only options that I have, because in the end, modern data stack says, well, it's all decoupled. So in the end, Fivetran takes care of extract and load, but transformation can happen in a totally different kind of place. And so I myself have to take care that the transformation part and the extract and load part are synchronized. They know from each other. And so that in the end, I don't run into, I don't know, some kind of weird running conditions where, I don't know, here we are still loading, but the transformation already starts, or we have some issues here and the transformation part doesn't really see these issues because like both systems are not connected. So this is what I can do on the Fivetran part. Again, like it's not really so much what I can do. How does this look like when we do it in Rivery?
So we'll see here now that like this river has completed running. So it took like 1 minute, 23 seconds, kind of load all that data. So the next step that you'd want to do is going to be like the transformation. So again, like you said, Timo, like no one kind of wants to end this just at like the integration part. Like there's always going to be some like downstream process that needs to like process the data, right? So with Rivery, what we do is what we call like these logic rivers, right? So these logic rivers actually let you orchestrate like an entire like end-to-end process, and they're built off these blocks called logic steps. And a logic step can be multiple different things. It can call like a river to run over here. So we can call like that same, BigQuery to Snowflake river to run that pulls our metadata, right? And then after that, like what we can do is we can call like another different option as well. There's like an action step, which calls like an API. So if you just wanted to like run like a DBT model, you could do that as well and trigger a DBT job to run. Alternatively, if you wanted to do something else, like you wanted to run something within your Snowflake instance, for example, you could actually just run that push down, SQL or that SQL-based transformation within Snowflake right in Rivery. So from here, you can actually just select Snowflake, your Snowflake connection. And on the source side, you can just put in like a query. So this is like a query I've generated that kind of queries that same metadata that we looked over, and then filters on the data for, New York data, and just has like where an object was created, I guess, or began after the 1900s, right? So you can run a quick query over here. It'll give you like a brief pop-up of that data and what that looks like in Snowflake here as well. But what actually happens is that using this function, the results of this query can actually be stored immediately within the target over here. So you can actually configure this to be the same, within the same Snowflake instance to be, the metadata, but New York, past 1900. And then this now creates a new table, and you get the same like append, upsert, merge, or overwrite functions. But it doesn't only end at like a where statement. Some people are using this to run like joins, to run like aggregate functions, like sum functions as well, or essentially anything else that you may want to query using like SQL or like combining different data sets. And like if you wanted to build this off of more like Snowflake stored procedures instead, you could even just call like a Snowflake procedure from within Rivery. And then this would happen right after the initial ingestion has occurred. So after the ingestion happened, then that stored procedure runs. There's one more function also that I wanted to mention is that aside from just the, calling a DBT job to run, running a SQL-based transformation as well, you can actually also call or store the data from here into like a data frame. And then you can import that data frame into what we call like a Python step. So this Python step, you can install any packages that you want, but you can really just import that data using like the Rivery platform. So you can do from Rivery data frames, import test data frame, and that results of this query that we stored over here are just being stored in that data frame. And then you can do any transformations that you may want within that Python step using like pandas or anything else, or like scikit-learn, and you can just take that back in and write that right back into your Snowflake instance as well. So you just use that same data frame as a source, and then we write that into like our target table. And then all of this can be orchestrated using one river or this one logic river, and you can even schedule this entire thing just as you would one portion of it. So you can see everything from the ingestion to like the transformation, using like push down SQL into your Snowflake instance or Python, or if you want to call like a DBT job, you can do that as well, all within like this one river or one data pipeline.
Yeah, and like the good thing is like now when I built this up, so first of all, it gives me when it runs, so when something is failing, which can happen, I mean, let's say maybe like the source schema is changing a little bit. So I now already have just one place where I can check where, let's say that you have the issues, and you can see like which logic step is failing, why it's failing, and then you can just go in. So maybe like the Python script cannot execute because it's missing some information, or some, let's say a type has changed, and so this is why it's not working. But you immediately have the place where it's happening, and so you can just fix that and then run it. And I think another thing that also, like when it comes down to the rivers, is like that you can have this in different kind of environments, because like it might be that, for example, I want to extend a river. So I have like, say, okay, I want to change the transformation, something like this. So as far as I understand, I can do this not directly in production, which I would do in the other case, but I can basically do it in, let's say, a staging environment. First see if this works how I expect it to work.
Yeah, exactly. So we can just give this a title over here. So we can call this like the metadata logic river, and we'll give it a date as well. So the 15th of February, the 24th, and we'll just hit save. There's probably going to be like an error because I didn't fill out all the information that was needed. But after this is saved, you can actually just click on what we call like the environments within Rivery. And these environments are actually completely separate instances from one another. So you can use this in like the traditional, like, test stage and like production environment. Other people are using this to separate it out by like different, business units, like the marketing team, like the HR team want their own instances. They can do that as well. But you build out these like what we call deployment packages. So you can add like whatever rivers or pipelines are associated. So we just call this like a metadata package. And then we'll give this a date as well, the 15th, February 24. And you can tell it to move data from like the test environment to like the production environment. And then you can just select the specific objects that you want related to these. So if I'm looking for like that Met one that we created, I can just search for that over here, and then we can click next. And you can just, fill out a few of these if you wanted to add like, different parameters, or if you wanted to like add the connections in the next step. And you just click next, and then it'll automatically just generate that package. And then that package can be deployed, meaning it'll move that data from like your test environment to like the production environment. And it auto detects things like, what rivers may be related, if there's related variables and stuff like that as well. And you can kind of configure all of those within the Rivery platform as well. So you'll see over here that it's brought up this page that shows like related connections, groups, etc. And all of this can be deployed using the Rivery option. So one thing neat is also like those entire groups or kind of like pipelines are also come kind of prepackaged within Rivery sometimes in what we call these kits. So kind of like that entire pipeline that we just deployed from like, prod, or from like a test to a prod instance, we have like a lot of these pre-built as well for a lot of different sources as well as a lot of different targets. But we also have things like, being able to like execute like a DBT job over here within this kit. So if you preview it, it'll give you instructions on kind of how that can be set up, and you can just use that and it'll automatically import that, similar to like a deployment package, into like your account. This would import it into my test account. There's other things also here. So not just, triggering jobs, you can also like post data to Salesforce, for example, to like bulk update objects in Salesforce, or like even like update objects within like from HubSpot as well. So kind of more of like that data activation piece. So within that same like logic.
This is now, just let me quick stop there, because like, I mean, this is like the interesting thing. So like, we looked at the modern data stack part, and we saw, okay, like transformation, for example, is something where I already need something else. And finally, for the activation part, I definitely need something else. So I definitely have to have another tool that can take this kind of step for me to push the data that we then, so we loaded it with Fivetran, we transformed it with DBT, maybe like in DBT Cloud, or maybe often like maybe in another part as well. Because like, for example, you had this example. So it might be that we have specific data sets where we might need to use pandas and so on, because like we want to do specific kind of things, or we want to run some ML models additionally. And then in the end, let's say we create a lead scoring. So this can all something have these steps in between where we do this. And the final step for our lead scoring model would be like, yes, of course, we want to have it in Salesforce, because like this is like where the salespeople are working with it. And so this is where we need it. And so on a data stack, then I have to look, okay, which kind of tool or which kind of function can I introduce that can then load this data again here. And so, but here in the end, it's just like, it's another logic step, I guess.
Yeah, exactly. So like all you'd have to do would be click at the bottom over here, and you could just add in that last step over here. So like this could be like another action step, but then post data back to like HubSpot, for example. And then you could just choose like the data that you want to post back, like relation to like the properties, objects, and stuff like that. But same thing, like if you want to like create a record in Salesforce, we have like a kit that's available for that you can just add into like that existing pipeline. And now you have everything from the ingestion to the transformation, as well as like that data activation.
Yeah, that's perfect. We talked a little bit about context switching. I mean, this is what I really like about not having context switching. So because in the end, I can define what I load in the first step, which we did with the first river that you created. And then I can define all the transformation steps in between. And also like it frees me up. So, I mean, we often take DBT as granted for transformation, and for, let's say, bigger models, it's definitely a good way to do it. And I always recommend it to do it, or something similar. But I often also like have use cases where DBT then is like overhead, because like you have a very simple use case that you want to solve, and which doesn't really require a lot of transformation, or at least not a lot of SQL transformation in between. And so then I can just do it here. So I don't have to do anything else. So I can just create these two transformations. I can put them on the right logic block, and then it works. So, and yeah, this really helps that I don't have to go into like a different tool, make sure, okay, is it connected to the right data warehouse? Does it have the right access rights and so on? Because like, as we saw here, like at no step we had to configure, okay, how can this access Snowflake and so on? Because like it's just done with this one time. Snowflake configuration. Is there anything else that you would add, let's say, as a final step?
I don't think there's anything else I would add after that data activation, but you can kind of monitor the entire thing using this pipeline. There's a few other ones as well. Like if you wanted to like update like a Tableau dashboard or something like that, you can like refresh Tableau. So more like there's just different options for like that data activation. One thing I would note is that all of this can kind of be parameterized to move from one environment to another using what we call like these variables. So you can even parameterize certain things from like, your select statement from like the data that you're selecting. And then this can become like a variable that automatically changes or gets updated as you move from one instance to another. And it adds a lot of flexibility within the platform as well, where you can run like, there's a whole bunch of different like options and stuff, but you can like, loop steps and stuff like that. You can add like conditional logic here as well, where like you can add like if then statements before processes run. So really just, setting all those different like dependencies and stuff like that and like the management of the entire workflow.
Yeah, that makes sense. I mean, it could be like that you have similar things that you can use for different kind of teams. And so then, for example, but they have different, let's say, all need 90% of the same thing, but still like 10% is different. I mean, this is cool that you have the possibility to just break out one part, have a variable, let's say, okay, this is the HR, this is the growth flow, this is the sales flow, and then in the end, you can use it like this. That's really helpful. Okay, good. Then I would say we can wrap up. So again, for me, let's say the interesting thing is like that people are already inventing new terms for modern data stack. So let's say like postmodern data stack or I don't know, whatever, which in the end doesn't really make sense because like I think one thing that was important for me to observe in this market is like there is no logical next step of a modern data stack. So it's like evolution doesn't do this. Evolution doesn't say, hey, we just have one next step. So usually like you have, it branches out. So you have different kind of things. And I think like a very interesting evolution of the modern data stack next to other evolutions is really like what you can do with the modern data platform, because it's built on the principles of the modern data stack. You now have the possibility that you don't get locked in. But you still get all the benefits. And so when I work in these setups where, for example, we start out and we know that, for example, like we will not have 40 people in the data team in the next 3 years because like, first of all, you don't get 40 data people. It's just so easily. They're still hard to get. And still, like, we even don't want to have this kind of headcount. So, but we want to serve the business. And what I always liked about like getting started with a modern data platform is this operational layer that you just get in, which in the end enables me, maybe as a smaller team, to do much more things that I could do if I couldn't do if I had to stitch everything together and then add an orchestrator here and so on. So it takes me a lot of overhead away, and in the end, I can deliver these kind of results that I want to deliver for the business team. So this was always like, this is still a part that I really like about this and why I often like recommend for people to start with the modern data platform. Thank you so much. So it was really interesting to see how you can build it up and what are the differences in Rivery. So again, like talking about the second use case, I definitely like that I can get started in Python pretty quickly, but based on my experience, I often very fast come in a situation that I want to control what I want to do. And I prefer systems that give me this kind of control where I can really say, okay, I don't want to load everything. And I want to define how I load things. So if, for example, sometimes I just have small tables where nothing will really change. Override is totally fine. Then I don't really have to think about anything, because like this is kind of the safest method. But there might be other sources where I know I need different kind of approaches. So I like it that I get this kind of control over these things. So again, thank you so much for providing the insights into Rivery, and see you in the next session.